all the key features in lesson 12. Now we're actually going to be graphing quadratics that are written in Vertex form. So we're still going to identify key features, but now we also need to put those key features onto a graph. So I put the Vertex form here for you just as a reminder. Remember that A tells you if the graph opens upward or downward. If A is positive, the graph is opening up, pointing up like this. If A is negative, the graph is opening or pointing down like that. The larger the absolute value of A. So the negative just tells you that it opens down. Ignore the sign and just look at the actual number. The bigger it is, the more your graph is stretched. It's called a vertical stretch, and it gets taller and taller. So a 2 here means that it's twice as tall. A 3 here means that it's 3 times as tall. And of course, if you're 3 times as tall, if I stretched you 3 times as tall, you're going to get narrower. The H and the K give you your axis of symmetry and your vertex. So the vertex, remember, is at the point H, K. And since in the general equation there is a negative in here, that means opposite. So K is the opposite of the sign in the parentheses. So that's kind of just a little reminder from earlier in the week. This first equation, we are going to actually be writing the equation. So it's important to note here that for today's assignment, and if only for today's assignment, the A is always going to be 1. We didn't change it to any other number because that's a whole nother thing to figure out if it's a 1/2 or a 2 or a 3 or what it is. So A will only be 1. You'll just need to decide if it's a positive 1 or a negative 1. And then we need to find the vertex to find our H and K. So for example, this first one right here opens up. That means that our A is negative. And as I said, it's only going to be a 1, so we don't need the 1 there. And then our vertex is right here. So the coordinates of that vertex, the x coordinate is 4, and the y coordinate is -3. Those are our H and our K. So we're going to plug H, 4 in for H, and -3 in for the K. So we get x minus 4 squared and then minus 3. This would be a great time for you to pause it and try to see if you can do this second one. Oh, you guys, what am I doing? This is not negative. It opens up. It's positive. Hopefully you were wondering why I was saying something crazy. It opens up, so it's positive. So see if you can do this other one now. Okay. This one does, in fact, open down, so our A would be negative. The vertex is right here. That point is 1. And then 2. Make sure you look at these labels. Don't just count 1, 2, 3, 4. Look at the actual labels. So this is at 2. So that is our H and our K. So we decided that this time our A is actually negative. And we're going to put 1 in for the H, so x minus 1 squared, and then 2 in for the K, plus 2. Okay, so that's writing them. Now let's go on to graphing them. So we're going to, as a reminder, use all of these key features that we found in lesson 12 to put them on a graph and actually graph the parabola. Okay, so we're going to find the vertex and plot it. Find the x-intercepts or the roots and then plot those. Find the y-intercept, which we actually have to do a little more work if it's in vertex form. Plot it, reflect over the y-intercept, and then actually draw the parabola. This last step got left off a lot on the quiz. I had a lot of people writing the points but didn't actually draw the parabola. Okay, so we're going to do 2 of these. I'm going to do the first one, and then I suggest you pause it and try the second one. Okay, so because this is negative, right, in front, our graph is going to open down. Our vertex is H and K. So H is the opposite of the number inside. H is 1, And k is the number added or subtracted at the end. So k is 4. So my vertex is at 1, 4 right here. And I know that it's going to open down. Now I need to solve to find the roots, which are also the x-intercepts. Okay, so to find the roots or the x-intercepts, we substitute 0 in for y. If you're trying to solve for the x-intercepts, you put 0 in for y. And remember that since this only has the one x in the whole equation, there's only one x. I'm going to solve it not by factoring our quadratic formula, although you could if you want to multiply this all out. I'm just going to solve it like an algebraic equation. So I'm going to isolate that x. I'm going to subtract 4 from both sides. So I get negative 4 over here equals negative x minus 1 squared. And then when I subtract 4 here, they would cancel. To get rid of this negative, I'm going to divide by negative 1. And then I have to do the same on the other side, divide by negative 1. So that makes that positive 4. We need to get rid of the square root if we want to solve for x. If we want to isolate the x, I have to get rid of that radical. So to cancel a square, to cancel a square, I'm going to take the square root. So I take the square root of this side, and then I have to do the same on the other side to balance it out. A square root cancels out a square. They're inverses or opposites like addition and subtraction, so they undo each other. So we get x minus 1. And then remember, when you add in a square root that was not there and you're trying to solve an equation, you get 2 or negative 2 because you're trying to figure out what number squared equals 4. Well, 2 times 2 equals 4, but negative 2 times negative 2 also equals 4. So we need both solutions. And now I'm going to write them separately. I'm going to write positive 2 equals x minus 1. So this equation so that I can solve for x. And then I'm going to do a second one for the negative, just like we do when we are doing quadratic formula. So then we can solve each one. If I add 1 to both sides, I get 3 equals x. And on this side, x equals negative 1. So those are my roots or my x-intercepts. So I'm going to, on the x-axis, put a point on negative 1. That's right here. And then put a point at 3 right here. Okay. The other thing that we needed to find was the y-intercept. So be careful because when we were working in standard form, it was just the constant at the end, but that is not the case if it's in vertex form. To find the y-intercept, we actually need to solve. So when we were trying to find the x-intercept, we put a 0 in for the y. If you want to find the y-intercept, you put a 0 in for the x. So in place of that x, I'm going to put a 0, and then I'm going to solve this for y. So negative 1, right? Ignore, I'm trying to cover it with my finger. You guys can't see it. Ignore this negative for a second. 0 minus 1 is negative 1. Negative 1 squared is positive 1. So I have this negative, and then this equals a positive 1. But I still have that negative out there. So I get negative 1 plus 4. Which then is 3. So my y-intercept is at 3 right here. Okay. We need a fifth point, right? That's only 4 points. So if we think back to graphing before in standard form, because it's still a parabola, all the same things apply. We had that axis of symmetry through the middle. So remember when you find that y-intercept, you can reflect it over. You can use that fact that it's symmetric to flip it over and get an additional point on this side. So there are my 5 points. 1, 2, 3, 4, 5 points. However, this is not a graph of a parabola. This is simply 5 points that we plotted. You have to actually sketch the parabola. So starting at the vertex, parabolas are U-shaped. They're curved. So don't go, let's see, this is a don't do because I saw stuff like this. People did this and did straight line and straight line on the test, Parabola is a nice, smooth, curved kind of U shape. Okay, so it's not a V, it's not straight lines, it's not lines to connect the points. It's a curved U shape. Okay, so once again, there's one problem left. See how you do. Try it. Pause me. See how you do, and then come back. Okay. My 2 is positive. My A is positive, so it opens upward. My vertex is HK. The opposite of the number inside is 3. And then K is the number at the end, -2. So my vertex is at the point 3, -2. It's right there. My x-intercepts or roots I need to solve for. So I'm going to put 0 in for y. And solve for x. I'm going to isolate x. So I need to add 2 to both sides. I get 2 equals 2 times x minus 3 squared. Then to get rid of this 2, I'm going to divide both sides by 2. So divide by 2 and then balance it out. Divide the other side by 2. 2 divided by 2 is 1 equals 2 divided by 2 is 1. So these are gone. X minus 3 squared. I have to get rid of the square. If I'm trying to get x isolated, x by itself, I need to get rid of the squared. I can't move the 3 yet because that's inside the parentheses. I got to get rid of the squared first. Opposite of squaring is square root. So take the square root of one side and the square root of the other. I added in a square root to solve an equation. There was no square root there. So when I add it in, I get 2 solutions, a positive one and a negative one. And then on the right-hand side, a square root and a square are inverses, so they cancel each other out. And I'm just left with x minus 3. So here is our point where we separate them into 2 separate. I get positive 1 equals x minus 3, and then negative 1 equals x minus 3. And I solve each of these. So x is 4 is one solution, and x is 2 for the other solution. Since these are x-intercepts, that means that my graph is going to cross the x-axis at 4. So I'll put a point there. And at 2. So I'll put a point there. The last thing that we need to find, well, second to last, we need the y-intercept. And to find where it crosses the y-axis, x would have to be 0. So we put a 0 in for the x. Oops, I forgot my y equals. 0 minus 3 is negative 3 squared is 9. We're not going to fit on the graph. 2 times 9 is 18. Minus 2 is 16. So, woo, we're way up here. We're going to fake it. Okay. Assuming that we actually had a big enough graph, I would reflect that over onto the other side to get my 5th point over there. Oh, and I did a terrible job of graphing too. It's not easy on this sketch pad. I still missed it. Sorry, guys. Ah, it looks terrible. Forgive me. It's supposed to be a nice parabola shape, but mine is not.